I hope my screen is visible to everyone. Can somebody confirm the same, whether my screen is visible or not? So that's visible. So I have shared this specific project documentation where you guys will be able to understand about how to actually build this entire project from very scratch. Secondly, before we jump onto the project, I'll just walk you through the flow of this entire session. Firstly, we will cover the basics of RAG agents, like what RAG agents are, what are the problems that it solves. And then we will be building one specific project where you guys will be able to get a project and then you will be able to implement whatever theory that we have learned. So this is going to be a really interesting session where we will be covering everything from the very scratch. Again, you don't need any coding experiences or any other technical skills prior to this. And there is no prerequisite as such. So we can cover this from very scratch. Okay. So I guess we can get started. Any of you have any thoughts prior to we start the session that we wanted to? Is the session full about NNN? It is going to be NNN plus Supabase. So we will be using Supabase vectors, a vector database to store our vectors. So you'll understand the moment we start building the project directly. So let's begin with the session, right? So what usually happens whenever we are working with any LLM like ChatGPT or Claude, they are really great at giving us the responses where they have the public knowledge. They are really great at it. However, when we are working with certain set of data which involves private truth. For example, it can be company's policy, it can be company's mission, vision, etc. So if we are asking certain set of questions which relates to the private data, the personal data, the chat GPT will not be, or any other LLM will not be able to respond to us to its best. So this is like the hallucination problem which is there. They have their knowledge limitations. So whatever knowledge that they have, it is on public internet data, but it do not have the personal data like our medical reports, our records and other details. So for example, if we're asking like what is the capital France, or if we're asking how to build an AI agent, so ChatGPT or any other LLM can definitely answer the question. But if we are asking questions like what is the HR policy of my company, what is the leave policy of my company, or I had a meet yesterday and which was revolving around building a new feature. So what was the actionable items? Now here LLMs sometimes they hallucinate. They just made up their own data, their own actionable items, and sometimes they will ask you for references ahead. So this is like the hallucination problem that we usually face with ChatGPT or any other LLM. However, these LLMs have evolved over a period of time just to demonstrate. So previously, when I used to experiment with ChatGPT or any other LLM, they were able to they were hallucinating to a great extent. So prior to this session, I tried experimenting a lot with the same. So for example, we were one of the questions that I asked, what was the exact sitting capacity of first prototype of the Apple One computer or so demonstration flow? Now here it actually understood that it is a this is a hallucination plus RAG demonstration because all these questions that I'm asking that makes no sense. Similarly, I asked one question regarding who won the Nobel Prize in AI. Now, what usually happens earlier, ChatGPT or some LLM used to hallucinate and will find some Nobel Prize not in AI but somewhere some in some other niche and will get back to us with an answer. However, these LLMs have evolved for a period of time, and this time they are actually responding to us with the correct answer. So this hallucination problem has definitely evolved over a period of time. However, there can be instances where these LLMs can hallucinate. So this is like the problem which RAG solves. Here you might have a question. Like, Vipin, what is the point of building a RAG agent if we can just upload one specific document here and ask questions relating to the same? Now, this works when we have some limited set of documents. However, when we have like really great set of docs, then this is the point where things get complicated. So, for example, if we have for example, if we have multiple set of documents, so there are two problems associated. Number one, as you have the multiple documentation, so your input tokens will increase because these LLMs will go through the documentation. So there will be higher token consumption. Secondly, as your context window increases, as your input increases, the quality of responses actually deteriorate. So in fancy term, we call it AI ticking, if I'm not wrong. So this is where RAG agents comes into the picture and solves this hallucination problem. So what RAG agents are? Just to give you more context about how it actually solves the problem. So if we are using a RAG agent, here there is better accuracy because AI can actually go through our documentation, go to the exact truth, and then they'll be answering the question. There is better efficiency in terms of the responses because they have the access to the relevant set of data. And again, we get personalized in LLM personalized responses here. Just to walk you through how exactly it works. So we have
Uh,
multiple set of user
just a
data.
second. Vipin, are you sharing something?
I guess my screen is visible.
I can't see
Yes.
anything.
Yeah, within your screen is visible to us.
Okay,
Okay,
is
then
it
continue.
Yes, it is visible.
okay? Great, great. So here, what usually happens? Firstly, we have the user data. So whatever user data we convert that into a specific structure such that that can be accessible by the different LLMs. So we'll be explaining about this RAG frameworks ahead in this specific session itself. Then whenever we are working with these LLMs actually firstly drive that information from the database that we have. Then it gives us the accurate answer based on the context that we have. So in layman terms, what a RAG agent is, it is just like an open book examination where an AI tries to answer the question, but it can also refers to our personal data. It can find the relevant databases where our information is available, and then it can give us better responses with that specific context about the query that we are asking. So just to explain how exactly this entire RAG lifecycle works. So firstly, whatever raw data that we have is converted into a text. So in case it is a text file itself, we then embed that into vectors. Now what vectors is, so whenever we are working with any with these LLMs, these machines don't understand words, they read mathematics. So for example, we have this letter as apple, APPLE. So this is actually converted into numbers. So what this is the part where we convert those text into vectors. Then we store all that vectors in a database. So how do we convert those text into vectors? So there are multiple embedding models. So we have Gemini, we have OpenAI. So they do have their embedding models, which can help us convert our text into vectors, and then we store all that vector in a vector database. So just to give you more context, how we will be doing this in detail when we will be working on a project. But just to give you more context on how it is being converted and how it is stored, I'll try to just show you how it is being used. So firstly, we convert all those text into vectors and then we store. So for storing purpose, we can use something called as Supabase. So we can create a project here in Supabase itself. So I guess I have a project for RAG agent. Um, so here we have this specific documentation table. So here we have all the content. Then we have embedding. So all that if you're able to see here, every specific content is stored in a in a in form of number if you are able to see here. So here, whenever we have to retrieve that information, so these LLMs do not search this text, these words. They actually search via these numbers. So this is where our first of all the our token consumption is actually reduced. Secondly, we are able to find the right context for our query, and then our query is being answered by the LLM. So just to be on the same page, and just explain again what exactly I'm trying to show you. First of all, we convert our entire data into text. Then we convert those text into vectors using embedding models. So these are free embedding models, which helps us convert that into vectors. Then we store those vectors in a vector database. So for that, we are using this in this Supabase. Alternatively, we can use Pinecone. Pinecone is a great tool that people use in order to store these vectors. Then this is like the query phase. So for example, this is like I am giving every single context and I'm storing every single context in a database, which is here. Similarly, over here itself, there is retrieval, augmentation, and generation. So, for example, if I ask GPT for example, I'm working on a product management or at a product management role where I have multiple set of meetings and I have multiple actionable items from the different meetings that I had. So I can feed my meeting notes to this specific vector database. And if I ask, hey GPT, I want you to help me out in finding out the actionable items. So what ChatGPT will do? First of all, it will retrieve the relevant data from this specific vector database that we have here. Then in the next step, it will add our context. So first of all, it will find the right set of data for our query. Then it will add my context, which is return to me with the actionable items. And then it will generate the final answer. So it will take this specific vector database context. Then it will take my first query into the consideration. And then it will generate the final answer for. So this is where the quality of responses increases. It is where our token consumption reduces. And using RAG agents itself, the hallucination problem is being fixed. And we are able to get the right set of data, right set of responses, just because of the fact we have stored everything in vectors. And these LLMs are able to call the right specific data when they are returning to our solution, returning to our query. Any doubts so far to whatsoever we have discussed? Any doubts? Anyone? Any of you have any doubts?
Yeah, I have one question. So the hallucination problem, what exactly it is? Like, how does it avoid the fabrication and removes hallucination?
Uh, okay. So the problem is when we are giving many information to ChatGPT at once. For example, if I'm uploading 43 documentation to ChatGPT and say return
Okay.
to me with actionable items. Now, in fancy terms, over a period of time, since we have like the 43 documentation, and all that 43 documentation will have many words. So when these LLMs go through the same, so as the number of documentation increases, first of all, the token consumption will be on a higher end. Secondly, these LLMs will start hallucinating because of the higher input that we have. So their response quality reduces over time. However, earlier they used to hallucinate a lot, where they will end up making some arbitrary data and sometimes arbitrary responses. However, these LLMs have evolved over a period of time and improved themselves, but still the problem is there sometimes. So with RAG agents, this entire problem is being fixed 100 is being fixed to almost 100%.
Okay. Got
Any other doubts? Okay, I guess we can move forward then. So this is like how the entire RAG agent's life cycle works. So again, we convert that into vectors. So this is how, so you will be able to get a better understanding when we are when we are working on the project itself. Now, this is something called as a chunk. Okay. So this is uh, where, for example, we have multiple data sets. I mean, multiple data, which has been converted into vectors. So, for example, we have multiple taking that product management example itself. So, for example, we have multiple meetings regarding a specific feature. Similarly, I have maybe search feature is one of the features where I'm currently working upon. And I get multiple actionable items around the same. I have multiple meetings transcript and from the same. Similarly, I have another meeting around product management itself, where this time my meetings is around user journey, or maybe uh, the meeting is around cart or maybe product checkout. So this is like the chunking process where instead of storing everything at one specific place, we create different chunks. Like all of the meetings transcript regarding my search feature is one chunk. Similarly, we have another meeting which is revolving around the card feature. So all that those transcript is stored in some other chunk. So this way, with chunking, we can actually store the larger set of data into different manageable segment so that we can find the relevant chunks ahead. Okay, so it is like the same process that I have explained previously. Okay, so this is, for example, we ask a query that the users ask a question. So firstly, there is a query vectorization. So it will find the right set of vector, and then it will return to me with the right set of answer. So for example, I'm asking about, uh, just let me know about the actionable items from my search meeting. So it will first of all find my meetings around search feature. Then it will find, okay, this is the meeting transcript. This is like the problem statement we were discussing. And then it will retrieve that context. Then it will add that context to the first user query. And then it will give us the answer ahead. So it is like the original question that we have. Then it retrieves the right set of information, and then we have a augmented prompt, and then we get the final response. So I guess that's about the basics. So for this entire project, we will be using Gemini, and we will be using Supabase for storing our vector datasets. And then we will be using Anatan for creating this entire system. Any doubts to whatsoever we have discussed so far? Any doubts?
Can you explain the workflow again?
Yeah, sure. So how these RAG agents work? First of all, we store all set of information in a specific vector database. So this is like, so how it works, first of all, you ask a question. So first of all, instead of directly answering the question, it will not directly answer the question, but it will find the right set, it will find the right set of information from the vector database. So for example, I'm asking for example, in this specific example, user queries, what were my marks in English or whatever subjects. So it will find, okay, Vipin is referring to his marks. So it will find the chunk where my database have the information about my marks. So it will find, okay, Vipin.
अरे अरे क्या हुआ सिर्फ सिर्फ टेस्टर चाहिए था सिर्फ टेस्ट
So what it will find the right set of vector here, then will take that vector into context. and then whatever user query that you have and whatever context which was retrieved. So it will take both into consideration, and then it will give you the final response. I hope this answers your question.
Yes, thank you.
So I guess now we can move on to the project that we are going to build here. In case any of you have any further doubts, you can drop the same in the chat box. So what project that we are going to build here? So it is going to be revolving around meeting transcription itself. So I have provided this a specific documentation in the group itself. So here I have attached something called a Google Drive folder, then a Gemini API key, the Gemini API key one. Just so I guess you all have access to this specific uh, file. Are you guys able to access this specific folder? Yes. Restricted. Okay, anyone with the link can view this specific file. Okay.
Yes,
So
we can access it.
great. So this is like, so what I have done, I have like added 5 different meetings in a Markdown file. So this is meeting 1, meet 2, all these meetings are around different domain definitions. Now the next thing that you should have is to have a account. You can create an account and run it, and it is a node which you guys can use to create AI agents automations. And you get a 14 days free trial. And if you want to use it for absolutely free, you can. It is an open source tool, so you can host it either locally on your device, or you can either use Hostinger or maybe Oracle Cloud. Hostinger also is paid, but you can use Oracle Cloud for your specific purpose. So this is how your screen would look like when you're using Editor for the first time. And the very first step is to hit on just create a workflow button. So this is how the project would look like. First of all, just name it as a RAG agent. And I hope you have account on this specific. And in case you don't have any, it won't take much time. So you can either use a temporary email, or maybe you can use Gmail to create an account on this specific tool. Similarly, you need to have an account on something called Supabase. So we'll try to create a fresh account for this specific session. So let's create an account on Supabase as well.
We can continue with ChatGPT, right?
Sorry.
There was an option to log in with ChatGPT, so we can use that, right?
Yeah, I guess to log in, you can use anything.
Okay.
This is not a fence. So let's create a new project. Let's name it as RAG agent. So this is how the entire platform looks like when you're uh, opening a new project in Superbase for the first time. Now here you need to refer to this specific documentation, and you will find something called these SQL queries which has been attached here. Now how actually this documentation is taken from N10 itself. So all this documentation is from N10 docs itself, which I have taken and compiled at one specific place. So first of all, you need to copy this one. Go to Supabase, go to SQL editor, and paste it over here. Once you're done with it, the next is to
Can you please go a bit slow?
search. So here in Supabase itself, I guess all the documentation is attached over here. There is one typo here that I have just observed. So just ignore this specific hyphen that you're able to see here, which is in red, and then just take rest of the SQL query which has been written over there. So firstly, just copy this one and then copy this one. And in order to run the same, just uh, hit on control enter and this entire SQL query will be run. So in the table itself, once you run all the queries, you will find a table named as documents. Now, this is the place where all of our content, all of our metadata and embedding will be stored. So just to be on the same page and just to explain how exactly this is being, the very first step is to create an account. Once you create an entire account of this platform, this is how your first screen would look like. Just go on the left hand side and find SQL editor. Copy these two codes, which is copy these two SQL queries, which is written here, which is enable the PG vector extension. And the other one is create a function for documents. Just just to point this out, just ignore this specific hyphen. There has been extra hyphen which is there by mistake. So just remove that when you are pasting the same. So just select from here till end and just paste the same over here and hit on control enter. So your entire query will be executed and you will find a specific table in your table editor section, which is the documents. I hope this is clear to everyone. In case any of you have any doubts, please let me know.
Vipin, I have two doubts.
Okay.
Yeah, so first is, why do we need SQL? And secondly, if someone wants to build any other kind of RAG agent, then how would they know which SQL query to use? So how do you find
Okay.
that?
Oh, sure. So even I don't know how to use SQL. So what I have done, I have referred to the documentation which has been given by N10 itself. So for example, what I have done is N10 dot docs N10. So almost all the tools have their own documentation. So for example, if I'm going to the N10 docs, here I'm supposed to search on Supabase vector store. And here itself, they have like Supabase quick start. And in the SQL section itself, I have this specific documentation. So it is the same SQL query which is being used here. The only difference is here the embedding is 1536. But in the code that I have in the SQL query which I have provided, here uh, the embedding is 3072. It is because the embedding models which provides us 1536 are discontinued and I'm unable to find the same. So this is like the only reason. This is the only change which is there. And whatever SQL query that I'm providing, it is from the documentation itself. So these tools have their own documentation, and we are referring to the same. And in case anyone have zero idea about running these SQL queries, so there is a alternative called Pine, but able, I'm not using this at this moment because of the same reason, and it is the embedding models of 15360 these are discontinued. I'm unable to find those set of models at the moment who can help, which can be used in order to convert those text into vectors. I hope this answers your query.
Yeah, yeah. I think it's clear. Just that, how would you know that this is discontinued? Did you check that it is not working and then you went
Yeah,
around and looked for 3072?
yeah, I have researched about this. I tried with 1536, I tried 768, and I
Mm.
found that the free ones are not available. However, there are alternatives available. But the models which is being provided here by NITN, it is not working at the moment.
Got it.
Now, since I guess you all were able to log into NITN platform, so just to give you a small recap from the previous session, the very first step in any automation or any AI agent that we're building, the very first step is a trigger, which is which will execute the entire. So for this specific use case, we are just using trigger manually at this point of time. So the very first trigger point is going to be the manual trigger. So the moment we hit on this button, this entire code will be executed ahead. Now we will be adding a drive here. We are adding drive here in order to get the relevant files which is stored over here and share with you all. So these are like the 5 different meeting nodes for this specific session. So here we need to search for uh, Google Drive, and here you will find an action called search file slash and Google. So we need to search that. And in case you're logging into this platform for the very first time, so here you can create your add your Google accounts. So you need to hit on create new credential, sign in with Google. So it is similar to any platform that you log in to. So it uses zero auth authentication. So for this specific case, I am just using uh, one of my old account just to showcase how you guys can log into your Google account. Provide the relevant access so that anyone can access these files and uh, help. They can create the entire automation, right? However, my Google account was one, so we'll be keeping that here. And then, in order to get that specific folder which is here, we can hit on add filter and search, click on drive. And here we can find the exact. So this one, I go ahead and just copy this URL and paste it over here and hit on execute step. Session here. Now we got all the 5 files which is there. Just to explain once again. the very first step is we hit on this execute button so that our work will be executed. Then we added one Google Drive one. We added the relevant credentials. And here in this, we need to hit on this add filter and select a folder because we have all of our files in this specific folder. And then select that specific folder, which is exactly this one, which is rag agent section. So you need to select the right folder here so that it can get the right set of files which is there. Now the next step is we will add another drive link and a drive mod. And this time we will be downloading these files. And here it will be dynamic in nature. So we will go to this specific section, which is from list, and we need to switch to by ID. And here we need to just drag and drop the same from here and hit on execute button. Now we have all of our files downloaded. Now we have all of our files here. Just to demonstrate it once again. Firstly, we will be using this execute the workflow button. Then we will be adding a Google Drive to search that specific file. Then we are adding another Google Drive just to download those files. Is everyone on the same page? Can we move forward? Any doubts so far?
Sorry, I missed the second step where you are saying this download. I mean Google Drive to
Yes.
download.
Yes. So this is like Google Drive, and here the operation will be download. And in the file section, by default, it will be from list or maybe by URL. We have to switch to by ID. And from here, we can actually drag and drop these variables. So we need to drag and drop the file ID here so that it can download all the necessary file which is there. Okay, now here what we can do, since we have this specific files available in this specific step. Now the next step is to convert these files into vectors, which was again one of the steps in our project, in our track pipeline. So far we have the raw data into text. Now we are at this specific step where we need to convert these text into vectors and vector database, store that into vector database. So in order to do that, firstly, so in this specific case, we have only 5 files, but there can be cases where you have multiple set of files, you have 30, 40 files. So for that specific use case, you can add something called as loop over item. So what loop over item is, instead of adding all of the 30, 40 files at once, it will perform this entire action in batches. So you can add the batch size to be 2, to be 5 accordingly. So it will convert only 5 files initially, then it will convert the next 5 files and the next 5 files. So if you're working on rack setups where it involves many files, so for that specific case, you guys can add something called as loop over item. So what this node does, instead of converting or working with all the 30 item at once, it will uh, do all that in loops. And we can even set the batch size, which is fine. So in case you're working with larger set of data, larger set of files, you can add this loop over item. So in order to add that, you need to just hit on this plus button, search for over item, and just add the same over here. So this is how it will look by default, and it says replace me. So it is like what actions needs to be performed, then it should be then it should go in the loop ahead. So just delete this replace me button and just hit on this plus button and search for Supabase. And here you will find something called a Supabase vector store. And here at this point of time, we are adding documents to our vector store. So we need to hit on this add document. Now this is how it would look like so at this step, we are adding data to our vector database, which is completely blank at this point of time. And so how it will work, and then you need to connect uh, this specific node to this. So it is like every single time only 5 documents will be added to our vector database, then the next 5 and the next 5 and so on. Now, I hope this is clear to everyone. In case any of you have any doubts, please let me. I guess we can forward them. Any of you have any doubts? You can give me a thumbs up if everyone is aligned on this project so far. Then we can move forward. Now here we need to connect our Supabase, this is specific project, to our NetApp so that this specific data can be added to our this specific data, this specific vector data. So for that, you need to, again, this is how your project would look like in Supabase. Go to project settings and go to API keys. And here you will find something called as secret keys. So copy this secret key, go to NetApp, go to Supabase vector store. So I have already added 2 IDs. I will add another one for this specific project. Just paste the secret key over here. And for host, it should be your project URL itself. So you can find that. So this is like the project ID. And from the project ID itself, you will be able to get the project host link. So you can find the same over here, which is the API URL. So we don't need this entire URL. We just need this supabase.code. Go to this specific, just keep the host till the project ID so and dot supabase dot and then hit on save button. Now we have successfully connected our this is specific SQL, this is specific Supabase to our NetN instance. And here we will again find our document table, which is here. Now at this point of time, we have successfully connected our Supabase to this specific NetN. And I hope you all are aligned on this specific this project so far. I'll try to repeat this portion once again, right, because I feel people might got confused on how to find the relevant keys. So first of all, you need to go to your Supabase, go to your project settings. There you will find something called as the API keys. At the bottom, you will find secret keys. So you need the specific secret key. And here itself, if you go to data API, so you will get the API URL. So you need to just get this post link, which is this part, https telsupabase.com. So you will be you need to you will get the same there, and you need to add the relevant secret key here and the host here. I hope this is clear to everyone. Any of you have any doubts? Uh, Please repeat the steps. Yeah, yep, Nikhil, where exactly you're stuck. I'll try to help you. Okay, I guess. Okay, great. Now, since we're done at this specific stage, so we have our data here. We are at this specific stage. Now, here, what we can do is we need to add an embedding model. So in order to add an embedding model, we will, so there are multiple embedding models that you guys can see here. So we will be using Gemini, Google Gemini embedding model. So this is how, if you're using this for the first time, your you will you have to again add some credentials here. So I'll just try to add that once again for this project. So in order to get the API keys, you need to refer to this project guide, implementation guide, which is there, and go to this specific website, which is aistudio.google.com. So we'll try to just open the same here. So you will be redirected to this specific page, and you need to get the API key. Just give me 1 second. So in order to get the Gemini API key, I have provided the relevant documentation. So you need to go to this specific website called Google AI Studio. And if you're creating an API key for the first time, you need to hit on this create API key. So you can name it anything. So at the moment, I'm writing it like agent session. And in case you can create a project in case you don't have any. So you can name it anything and then create a key. Now, whatever API key which will be generated, do not share that API key with anyone. Keep your API keys to yourself and just don't share it with anyone. These are, because someone else will be able to call your specific API call and I will be deleting this after the session. So you need to get this API key here and go to NetN itself and add new credential.
You on mute?
Oh, my God. Okay, so just to explain what exactly we have done so far here. So we added a vector data store and then we added the Google Gemini API key. And in order to get Gemini API key, you need to go to this specific website called as Google AI Studio. And the link for the same is also attached in this specific documentation. So you need to just open this specific link and you will be redirected here. You can hit on create API key, name it anything, and then you will get an API key. Just to make sure, one thing that I just want you to take into consideration, which is never share your API keys with anyone. In case anyone get access to your API keys, they will be able to call your Gemini and they will be able to exhaust your limits. And so for that reason, you should not be sharing your API keys with anyone. So in order to just get your API keys from there and then hit on this specific embedding model, connect your API keys, and then here the default data loader, you need to change the JSON to binary because whatever data that we have in this specific step, all the files are in binary. So we need to we need to select binary here instead of JSON. Now here you will find something called what exactly we have done. What exactly we can see here, whatever page content is, it is converted into vectors. So just to show you here, just give me 1 second. See. Okay. So what we were able to do here is we were able to convert our entire data into vectors and we were able to store all that data into our vector database. So just to show you whatever data that we have. Now, if you open this table editor and go to the documents, you will find that every need has been added here in this table. We have the content, we have the metadata, and we have the embedding. So everything is now converted into numbers. I hope this step is clear to everyone. Any doubts so far to whatsoever we have done? Anyone, you can give me a thumbs up if everything is clear and you guys were able to follow. Hello. Uh, you guys can just give me a thumbs up if everything is clear and you guys were able to follow along. Am I audible by any chance?
You are audible.
Yes, we can forward. Now, so far we have were able to complete this preparation phase where we converted our entire data into text, text into vector, and vector into our data set. Now the next part is creating a RAG agent where we will be using this specific database which has been stored here in forms of vector. To create that, we will first of all add a chat chat trigger so that we can demonstrate how exactly it works. Now here we will add a node called as AI agent. We need to search for AI agent. In case you have joined the previous session of ours where we tried explaining how you can build your first AI agent from very scratch. So an AI agent has basically three different components, which is like the chat model, which is the brain. So here we can use Gemini as the brain. Then we can add a memory. So uh, just to remember the previous messages, we can attach a memory. So I'm currently attaching a simple memory. But in case you wanted to use this in some production level applications, so using Postgres would be a better option. And in the tool section, so what tools are? Tools are the external capabilities that we provide to an AI agent so that it can help us better answer our queries. So here we can add our supervised vector store where we have all of our data stored. And here we need to again select the table names. In our case, it is documents. And again, we need to attach an embedding model. So we will be using Gemini. And here we need to give a description about when to call this a specific tool. Here we can just write call this to answer queries relating to meetings. Then in the AI agent itself, we have something called as a system output, and then we have something called as the user prompt. So user prompt is basically whatever the text that any or that the user will have. So that is going to be the user prompt. Similarly, we will be having something called as a system prompt, which is going to be the fixed component and the fixed prompt in an AI agent. So we can just write it, you're a helpful assistant. Your job is to help user with the, you can just generate a prompt with chat GPT itself. I guess I forgot to add this to the project documentation. So I am just dropping the same in the chat box here. Yes, I forgot to add this to my. So you guys can copy the same from here. We'll share the updated documentation in the community itself. Let's open the chat. Say hi. Now it is responding accordingly. Then action. What are the actionable items from my phone? Let's take some of the example. From my this. So here, based on the meeting that we had on 4/5 of August, which is there in this specific database, it referred to me with the actionable items and the relevant deadlines, relevant point of contact, and other details. Now, how it worked here, it first of all take the user input into consideration, and then Google Gemini search for that specific meet from this specific vector data store, and then it took this specific context from this vector store, and then took the user prompt which was there. Then it combined both of the queries at once, and then it returned to me with the final answer. So this was like the uh, RAG agent that we were able to build in this specific session. We'll try to repeat this part once again so that in case you're stuck at any point, you will be able to follow along. So firstly, we added a chat message node. So it will act as a trigger. So the moment a user query has been received, it will respond to the user queries. So then we added an AI agent where we added a brain. So in our case, we added Google Gemini itself. Then we added a simple memory so that it can remember the context. So for example, when I said hi, so it will remember both of these two texts. And then we added something called a Supabase vector store. And then we added something called an embedding Google Gemini. Now the purpose of this Google Gemini is to find the right set of chunk from this entire database which is attached. So this actually becomes really easy for Gemini and these embedding models to find, because whatever data that we have added to this vector store, it is in the numbers. So machines can actually find these numbers very easily and then find the relevant context accordingly and return to our query to its best. So there is like, so sometimes you might say, Vipin, there can be cases where we had multiple set of meetings around the same niche. So so there is possibility that this vector store method can even can be hallucinating. So here we have something called as a re-rank result. So when I say limit, so it will find the top 4 chunk for our answers. Similarly, if we turn on this re-rank result, so we will be able to add something called as a re-rank model. So I have not yet added any credentials, and I have not yet figured out free tools for this specific part yet. So we'll not be covering this in detail. So how it works, it actually re-ranks the responses. Like so this helps us identify, okay, these are the top context which is important for answering this question. Simultaneously, it ranks this specific model, ranks the user responses which has been received. So this was like a very basic level RAG agent system, which can be implemented in your real use cases for your job. Any doubts to whatsoever we have discussed? Or maybe at any point you guys are stuck and want me to repeat that part once again.
In the discussion, you brought about that the point of limit is equal to 4. What
For
exactly is that?
Okay, so basically when I said, so for example, in our case, we added these 5 different documentation. And if we refer to this specific content, so here we will find that so not every single content is added in one specific cell. It has been split into different batches. So even the meeting note 3, which is around engineering and AI infrastructure review. So it is like one of the cells is referring to that. Similarly, other cells are referring to that same. So we are not storing every single set of information in one specific cell. So so whenever we will be using this 4 as the limit, so it will find out the top 4 cells from here, which is relevant in order to answer our query. Similarly, we can increase this number according to the number of data that we have at the back at our vector database. So it referred to this page content 4 content. Then it referred to this meeting node 1, which was a product strategy 1, and then other. So it is actually finding the right set of chunk first from this specific date vector database, and then it is returning to us with the final answers.
What if the data is present in number 5, ID 5? Like
ID5,
we
I mean,
cannot
how many?
it
How?
like we
Sorry, could you
cannot
please come
know.
again?
Yeah, I was telling that we cannot know where exactly is the document. Like for example, if you have 40 meetings and that 40 meetings is converted into vector, and while setting the limit, we might not know how many vectors are there to set the limit, right?
I think when you are working with this itself, so it comes with hit and trial itself. So over a period of time, you will yourself find out. So how many, what should be the ideal number there? So for
Okay,
example, when in this specific tool itself, where this embedding pass size is 200, so you can even play with these numbers so that you can store more context in one specific liner itself. And then in this supervised vector store, so since we had only five files in our data set, so we were able to add the same here. However, in case you have really great set of data, so you can call even more numbers depending upon your use case. So it is some based on my experiences, it is mostly this hit and trial and finding the same based on what sort of data that we at the what sort of data we have at the backend and how long that data is.
okay, okay. So thank you.
Will you provide the documents in WhatsApp channel? Nikhil, we have shared the document in the community. It is already available there. Guess we can stop the recording now.